Let's try to understand the law of equipartition of energy. Now, what this law basically tells you that for every degree of freedom, you have energy. Now, the first question is, what are degrees of freedom? Okay, now see, you have three types of atoms: monatomic, diatomic, triatomic, correct? Now, each of these type of atoms, they have degrees of freedom in the sense how they can move. You have translational motion, you have rotational motion, and you have vibrational motion, correct? So, every atom, monatomic, diatomic, triatomic, they have different types of motions. All right. So, monatomic, they have degree freedom of 3. Okay. Diatomic has 5. Triatomic has different based on linear or non-linear, but basically they can do different types of movement, and because of the different types of movement, they have different energies. Now, this law of equipartition of energy tells that each degree of freedom has the same amount of energy. Now, you need to prove it. Now, what we'll do, we'll take the kinetic energy of single molecule. So, one molecule has just translational. So, we'll take it as Et is equal to, look at the formula, half mvx square, half mvy square, half mvz square. For thermal equilibrium, average translational energy is what? Et is equal to half mvx square, half mvy square, half mvz square, but along with the bracket, because this is the average what we are looking at. Now here, there is no preferred direction, correct? It's just moving wherever it is. Since there is no preferred direction, what we can write, half mvx square is equal to 3 by 2 kb into t. The same thing goes for vy square also, along the y-axis, along the z-axis, correct? As there is no preferred direction, what do we have? Half mvx square is equal to 1 by 2 kb into t. Now the same thing goes for y-axis and for z-axis, correct? Now here what you need to understand is you have a very important point. The energy associated with each molecule is how much? 1 by 2 kb into t, correct? Now what did you understand by this? See, the energy is equal everywhere, right? So this is basically the law of partition of energy. All right. Now for diatomic gases, what do we have? For diatomic gases, we have 5 degrees of freedom, okay, which is 3 translational, 2 rotational. All right. So now what do we get? The total energy is going to become Et plus Er. Look at the formula here. Half mvx vy vz square, guys, that is for translation. For rotational, you have half I1 into omega 1 square plus half I2 into omega 2 square. This is for diatomic. Now, see, there are certain diatomic molecules, like carbon monoxide, they also vibrate. There is vibrational motion. If you have vibrational motion, then the vibrational energy is given by, look at the formula, half m into dy by dx whole square plus half ky square. Now, what you need to understand is that the total energy is going to be summation of all the three, that is translational, rotational, vibrational. Understood? Now, when you look at these three types of motions, we also see that there is a quadratic equation here. The vibrational having the highest degree, translational having the least degree. All right, so the total energy is given by the energy in the translational motion plus energy in the rotational motion plus energy in the vibrational motion. All right, so here the equipartition of energy is present. That is, in each degree of freedom, the energy remains constant. So this is the law of equipartition of energy.